By way of introduction, so I'm Molly. I'm a recruitment consultant here at Fruition IT. If you haven't heard of Fruition before, we are a tech recruitment consultancy based in Leeds, and we are really involved in the tech meetup scene and the event space across the region as much as we possibly can. We think it's really important to give back to the tech community and stay involved, and we know that a lot of people are missing that tech meetup scene at the moment, and we wanted to continue that engagement and continue that learning as much as we can during lockdown. So we started this webinar series and we called it Lockdown Learning. It's proved to be really popular, and it's been great so far, and so I'm really excited to introduce the seventh installment with Tim Lewis. Tim is the software engineering manager at DAZN. He has been coding since he was about 9 years old and has been in the sport media industry for over 20 years. So he knows what he is talking about. And he's going to be talking all around CICD implementation, the sorts of barriers that you might face when you're putting this into practice, and how to successfully implement it, especially in larger organizations, and you know, convince people that that's the right thing to be doing. So yeah, the talk will last for about 30 minutes, but if you've got any questions, put them in the chat. We'll get through as many as we can. Tim will answer as many as possible to the best of his ability. So yeah, over to you, Tim.
Thank you very much, Molly. Cheers. Hi everyone, thanks for joining us today. Just like Molly said, I've been in sort of tech for a long time. I've been a coder for an awful long time. Now, as I said, one of the software engineering managers at DAZN in Leeds. And yeah, so today I will share my screen. Hopefully you will see this now coming up. So yeah, I'm going to talk about successfully putting CICD into practice. So I'm not going to go too much depth into what CICD actually is, other than just because it's quite a big subject, but in essence it's continuous integration and continuous deployment. So let's move on. Right, okay, so like I say, I won't go into too much detail, but in essence I would say it's the automation process that allows code to transit from a developer straight into production. So what does that actually mean? You know, there's an awful lot of descriptions out there around this, and it's quite woolly actually, and I was looking for a suitable sort of kind of one sentence statement that summed it all up, and I actually found it difficult to find one, which is quite interesting. But basically what we're trying to do with the CICD sort of process is to quickly build code, iterate quickly, fail fast, tight feedback loops. So we do small things quickly. So every time you work on a bit of code, a little bit of product, a product feature, whatever that might be, you get it in front of your users as quickly as possible. And doing that allows you to react to any feedback, react to any problems, fix things quickly, get feedback quickly, improve your products, and actually properly, truly iterate. That's the main sort of the driving point behind CICD. So, having said that, you know, this all sounds very good. It's all kind of buzzwordy and like, oh yeah. You know, some of you I'm sure have heard this many times before. You know, and that's great, but it's kind of like, how do we actually make this happen? How do we do it? How do we put these sort of this statement in front of us here, the automation process that allows code to transit from a developer straight into production? How do we put that in practice? And I kind of think one of the main kind of questions and statements and kind of shocked looks you get is this. It's like, oh, wait a minute, straight to production? Are you sure about that? What about testing? What about, you know, what about risk control? What about change management? How do we do large UAT projects? What if we're just trying to do some partial features? And all these are really valid questions. The reason for going straight to prod is, as I just said, previously, you want to iterate quickly. You want to get what you're doing in front of users, and you want to get that feedback quickly. And by doing small, tiny releases, you lessen your blast radius of any release, so your risk's actually reduced. Now, there is a massive talking area around this, which we could go back and forth around for hours, I'm sure. But I think, or at least I hope, that out there in the industry, there's plenty of papers and blog posts and talks and presentations that explain, what CICD is and what it means. And, some of the big media companies in the world do this. Netflix do it, Facebook do it to a degree, Etsy do it, Amazon do it. The list is quite a big one, and these are all big companies with millions of users, and they do this. And the reason for doing that is the benefit it gives you in those small changes, that you limit your blast radius, you get code out, you develop your product quickly. But again, the question I always came up against and have come up against and still come up against to a degree is like, what about processes like change management? Now, change management is, a really kind of big thing in a lot of companies, especially larger corporations, where there's a business function that wants to know what's being changed in production and what sort of impacts it might have. Now, that immediately, in the way it's normally traditionally done, puts a massive blocker in the way of you just deploying straight to production all the time. The same is probably of UAT testing and traditional UAT testing. Like, we're developing a wide suite of features, and then we want to get our own internal test teams to try it out, make sure there's no inconsistencies, make sure it's actually the engineers have built the thing we actually wanted them to build, that sort of thing. And we want to do that before anyone sees it. And again, if you're doing small iterations, if you're sprinting or you Kanban or some other sort of agile lean method of development, quite often you'll be working on little bits at a time. So how do you release stuff to production when it's not all finished yet? These are big questions, and they are the ones that you need to address and answer, really. So the point I'm getting to here is, so given these, especially in larger organizations, how do you address them? How do you kind of face up to them and go, right, how do we deal with these? I always keep thinking, how do we work around them? How do we get around them? How do we ignore them? And that's not right. You shouldn't be doing that, really. It's like, how do you work with this sort of, older school way of working, perhaps, if I can be a little bit controversial? How do you actually work with people to get them to come over to the new way of doing things? So I'm just going to quickly reiterate why it's important to release to production all the time. And obviously, again, quick iterations, etc. But for me, there is a golden rule. That golden rule is the master branch of your code repository should reflect exactly what is in production. This is super important, in my opinion. If your master branch of your code repository isn't reflecting what's in production, when you get production incidents, and you will, everyone does, when you get production incidents, you don't know exactly where your code is. You have to start digging through commit histories. You have to go through different, maybe you're on feature branches, maybe you've got tags somewhere in the code. It instantly becomes more difficult to fix, to debug, to fix, and then to roll out again. If your master branch is exactly what you have in production, then you know exactly what you've got. Everyone's up to date. It's so much easier to start fixing things. Yeah. So, bugs are easier to tackle when everyone's on the same page. Everyone's at the same exact place in the code repository. It makes such a difference. It really, really does. It just makes anything like that so much easier. And one of the things that kind of, I guess, is a metric that is quite interesting, and it's one I've seen businesses use a lot. Is something called mean time to recovery, which is when we have an issue, or there's a production incident, or there's a bug in the software, it's like, how long does it take to get that bug fixed and rectified and released? Now, mean time to recovery is something that's used quite widely, I believe, and I'm not sure it's the most important metric, actually. I would suggest that if you don't already, the thing you should be looking for and you should be measuring is the mean time to discovery of a problem. There can be bugs in code that don't get uncovered or don't get reported for weeks and weeks. And that mean time to discovery impacts your mean time to recovery anyway. But the longer something remains undiscovered, the larger impact it might have. There's more code potentially you might have to roll back. There's more fixes that you might have to do, and any number of different business impact could be being added up. So your mean time to discovery is super important. And again, that is so much easier if your master branch contains exactly what's in production. So we mentioned that golden rule. And I'm going to come back to those three, well, kind of the main blocker, I think, that I've kind of come across when I've been trying to get this sort of practice, that kind of continual deployment piece into actually, into being, is change control. So it's frustrating. As a developer, you're kind of like, right, I love all this DevOps mindset. I love this whole continual deployment idea. It makes it so much easier. We get much from users. We feel like we're adding value instantly, constantly. And that's really important to me as an engineer. And then in a larger corporation, you can come across, and obviously I don't know how many people see this and how many people have got this going, but certainly I know it's in quite a few places, is you get something like CAB, the Change Acceptance Board, or whatever CAB stands for in your organization. Well, that change and release management, which, again, in my experience, typically has said you're not allowed to release anything to production until it's gone through the CAB or the change control and they say it's okay. And that is a frustration. That is a real frustration, because instantly, if you take it at that level, that instantly says, well, we can't do CICD. We can't have a pipeline running that is deploying code to environments and then it has to stop and just waits there until someone or a group of people has said, yeah, sure, that's fine. So that's a real problem, right? That's a real block. How do you get around that? And again, we have other things like, and I've seen this a lot as well, and it's something I used to say back in the day, is like, I'm not doing a release on Friday, but I don't need my weekends upset. That's just not a thing. Let's not do releases on Fridays. Let's be risk averse on that sort of thing. And again, change freezes happen in businesses for very good reasons. For example, in DAZN, you can be rest assured that if El Clasico is going on, we have millions of viewers around the world. The business is going to frown upon us if we're still releasing code during the time the game's being played. So, again, how do we handle things like that in a CICD pipeline, which is a full automation pipeline? How do we deal with these sorts of stuff? So these are challenges, right? These are difficult things to work around, or at least they seem so on the surface. But why do they need to be? So obviously, success baby saying, right, I'm going to change management. Now, I'll put the first point here, which is kind of one of the points which I think I've seen a lot of use, and it's proving to work, is something I've dubbed PreCap. So large businesses want some sort of change control, and it's a necessary process in a large business. The business need to know that what you're doing isn't going to break something. In a large business, engineering teams have less knowledge and less across what other engineering teams are doing. Especially, you know, we have development centers in Amsterdam, we've got development centers in Poland, we've got, you know, developers in Hammersmith, and we've got developers in Leeds. So we're not sat in the same room. We're not listening to, oh yeah, I'm going to release this thing that might change this thing next week. So we need people to say, well, actually, we know this is going on and this might have an impact. You need to think about it. So fitting that into a kind of CICD world, a DevOps world, I kind of dubbed this PreCap. So in my experience, CAB has kind of been I've written all the code, I've done all my testing, we're ready to push it live now. And it goes away to CAB, and CAB look at it and they ask you a few questions about what does it do, what's it changing, and you tell them, and then they go, okay, that's fine. Or have you considered these things? Yes, okay, that's fine. At no stage does anyone in this process actually look at code and actually look at what has been written, and probably doesn't have a great in-depth understanding of the change, you know, what it's doing on the sort of, you know, under the hood, so to speak. So why do you need to wait until you've written it all to actually apply for the change, to let them know? So we've started doing something called PreCap, where we apply for CAB acceptance before we start work on a story, on a ticket. And by doing this, change control know this is coming. We know we are going to release something within a window of time, usually a 2-week sprint window. And they can still look at it, what we're going to do and what the change will be, and then say, yes, that's fine, or no, please don't, because of this thing, have you done that? And that gives them the time to go away, maybe pull that ticket back into a bit more refinement, understand what the challenges might be, and then we can pick it up again sprint after, as an example. So to do that and sort of come back to my, well, we need to like do, you know, we do small iterations and we release the prod a lot. So in CICD, in our world, we can be releasing to production 20, 30 times a day. So if you do a CAB for every single release to production, you're going to flood your change control people, and they're not going to like it, and they're not going to be that happy with you, understandably. So we do one change request, which will have many releases, which are linked together. So they're all still tracked, they're still audited, and if any one of them goes wrong, it's still hooked to the same CAB, and then we've got decent incident management that can then, after we've rectified an issue, should there be one, we know we can trace it easily, and we can work out and we can make sure mitigation's in place for the next time. Again, that's linked into the next two, really: test, and monitoring, alerting. In a CICD world, if you're going straight to prod, you've got to test. Your tests have got to be outstanding. They've got to be thorough, and they've got to be useful and targeted. You've got to have, so you test, just that is probably the most important thing, and we'll come on to that in a little bit. And monitoring and alerting. I think I once saw a talk around DevOps, and the sort of thing I took away from it was a statement that says measure everything. Literally measure everything. The more data you've got and the more feedback you get from your monitoring and alerting on all your services, gives you all the information you've got to sort of say if something goes wrong, and you hope it won't because you're testing everything right and all your tests are good. But in the real world, when things do go wrong, you know exactly when they go wrong, and you know soon, you know quickly, which then links back to our mean time to discovery that I was talking about previously. But yeah, why wait until you're about to release to ask the business whether you can release when you can do so ahead of time? And we've started adopting this, and it works really, really well. Cool. So no release Fridays are quickly sort of like, essentially it's another code freeze, right? But it's kind of one brought on by fear. Like, oh, I don't want to do something on Friday if it goes wrong, or I might get called out on a Saturday. And it's like, well, yeah, when you're doing massive big bang releases, I completely get that. But we're talking about multiple releases a day, 20, 30 releases a day. So why fear a release on a Friday? You're used to doing releases. You release 20, 30 times a day. Releasing is just another part of your job. It's like writing a couple of lines of code. It's like a release. It's a common, normal thing. It's not scary. It's not a big thing. You do it all the time. So, you know, why limit releasing on a Friday? And, you know, presumably, you know, if you're working in a sort of more DevOpsy kind of way, you have support and on-call procedures anyway that you're going to be hitting out of hours. So you can lean on that. You know, no release Fridays should be a thing of the past. And yeah, change freeze. So change freezes, as I said earlier, are important. They mitigate risk. Like I said, we don't want to be putting at risk something that is, you know, one of our sort of prime products. You know, El Clasico, the Manchester Derby, the next Canelo fight, the next AJ fight, the Grand Prix, whatever it is, that big sporting occasion, we probably don't want to risk releasing around that. But again, how do we tackle that sort of restriction in a CICD world, which is all completely automated? And it's a good question. It is. And it's something we're still kind of digging away at. And it's not something we've completely solved yet, I don't think, but we have a path to doing so. And basically, what we'd like and what we're trying to work towards is to have a small service somewhere, which would be controlled by someone like change management, who can sort of publish when release windows are closed. So for the 3 hours around a football match, the preamble, the game itself, a little bit of the after. If our pipeline can go away to a service and say, am I allowed to deploy yet? It can go, no, please don't. You can try again in 30 minutes, an hour, however long the rest of the window is. And then that's fine. And it minimizes that sort of buildup of unreleased code, which CICD tries to get away from, to just specific windows. And also then allows the business to, rather than go, you know what, I bet most people have a change freeze between December the 18th and January the 2nd or something similar like that. It's like, again, you can start protecting specific areas of that now. Like, well, we've got enough support people up until the 24th of December, so let's just close it off over Christmas and Boxing Day. And then we've got a few people in on the 27th, so let's open up again. And it's an easier process to manage, and you can start minimizing those windows when you've got unreleased code building up. But I guess my notes here say let's get on to the real problem. So I realize time is moving on, and I've said this a lot. Automation, yeah, pipelines, automation pipelines, you know, it's all good, right? We talk about it a lot. How do we actually go about making that happen? And I think how and what we build determines our success. Now, the what is obviously very much driven by the business and product and what they want to do, right? But to determine so how we build it is like, can we split things down into small discrete parts that can be released on their own? You know, that's what I'm getting at here. Change how you build things. Change it so you can release small stuff. If it's a partial feature, first thing you build is, let's say it's a page, a new page on a website or something simple like that. What do? First thing you do is build a blank page with a feature flag that flags it off to the customers. Release that. Then add the first field, if it's a form. It's all feature flagged off on the page, release that. Build it up until you're ready to then feature release, and then you can just turn the toggle off. You know, and to support that, you can do BlueGreen releases, you can have Canary releases as well, just to make sure that when partial features go up, there's no unexpected side effects. For example, with a canary, you can trickle out 10% of traffic first, see if it's working okay, slowly ramp it up until you're 100%. There's lots of strategies like that. Automate everything. If you can automate literally everything, it makes your life so much easier on this sort of thing. Automate all the things. So quality of your code is directly related to the quality of your tests. Tests should be relevant, provide value, they should run quickly. All of these things are super important. You have to have really strong tests to make CICD work in a production environment. Without strong tests, you're going to run into so many problems, and you're going to have people shouting at you, and no one wants that, right? So, excuse me, test everything, test. It's the way you have to do this, you know. But they have, and to do that, you can write millions and millions of tests, huge test suites that cover every single possibility. But when you do that, you then start making your builds long, and that then causes problems, because during a build, no one else can commit anything, and you start queuing up stuff behind, and that's a bad place. You don't want to be there either. So your automation tests need to be focused, and need to be focused on good scenarios and obviously unhappy scenarios, but build your test suites up. Get your happy path sorted, get the obvious edge case sorted, get the obvious unhappy path sorted. Then as you go and as you discover things that break in the development process, as you're starting to build up a feature, add tests to cover it. Once you've tested once, automate it. If you find a manual test, exploratory testing, you find a problem, automate it. Make sure it never happens again. Run tests in parallel if you can. I realise time's running on a bit, so I'm going to move on to the next slide, which is, so this is an example test pipeline, and we use something along these lines to do our CICD. Now, it's quite a complicated diagram in some ways, I guess, and I've simplified it. Now, I think the takeaways from this are, in the yellow boxes, these are the sorts of tests that you can run. Now, these tests might not work for you. They might not work for the product you're working on. You might need more, you might need less. They're just there as an example. But they kind of show the kind of steps that we take before something goes to production. So we've got the initial test phase, which is essentially when someone commits something to the code repository, either on a branch they're working on, or well, yeah, whatever they do on a branch they're working on. Or unrelenting, or run any sort of unit tests, mutation tests if you do that sort of thing, coverage reports, whatever your process is in your development process, that's where all this gets run. And that runs every time stuff's committed. Now, if you're doing working on a dev branch, we tend to push stuff out to a development environment, which is ideally looks similar to what production is, but obviously it's very much a state of flux. It's a development branch, right? So that deploys as we would like to deploy in production onto our development environment. It runs smoke tests, component tests, integration tests, system tests, and if all those pass, you've got a green build. Now, bulk of your testing is probably here, right? This is where you do make sure your quality is good, where your engineers are making sure your quality is good, where your SDETs are making sure the quality is good. So when you actually do a merge request and pull the branch into master, it runs the same test again in test, but then moves up the pipeline to stage, then production, running less tests as it goes, because you've already confirmed that you can build green on your branch. That's the idea. Obviously, this is a lot more complicated than I've just skimmed over in a couple of minutes, but you capture most of your problems in that dev deploy and the initial test phase. Those two steps, when you're developing a small feature, do it on a branch, run this, constantly deploy to dev. When you get a green build and you're ready, code review, do whatever process you need to do in your engineering department, merge it into master, and then it goes. Now, you know, this is all very easy. Talk is cheap, right? But this is what we do. And when we get stuff into a master build, once it goes into test and stage, we very, very rarely see a red build. Pretty much, I'd say it's in the high 90s, all our builds go green when they're in production. So yeah, I realise I've skimmed over that, and there's quite a lot going on there, but this is just to give you an idea of how you build a test pipeline to support continual deployment. Or at least it's one way of doing it. So yeah, how do you sell it? This is the main crux of it, I guess. Is like, there will be people who like don't want the risk, they don't understand it fully, but it's, you know, how do you convince people that this is something they should be doing? Build it. If you can find a small service, if you're working microservices, or a small feature set or something, even if it's an internal tool, build a CICD pipeline, commit to it, commit to going straight to production on it, build it, make it work, get confidence in it, and start with something small and simple. So you start building up confidence in your own teams first, then demonstrate it. Get the people like change management, senior IT, all those sort of guys, all that process, demonstrate it to them. Actually invite them and kind of, hey, look what we're doing. This is how we think we should now work. This helps us because we get tight feedback. We discover problems quickly. We have no, code build up, which we don't know what's in production compared to what's on our master branch now. Show them the benefits, show them all that, and actually show them a build. Go through it, go through a build and say, look, here's what happens when I commit something that's dodgy. Look, it doesn't even get into the test environment. We've picked it up in our dev branch. Go through that and prove it, and give them the confidence that you can do this and make it work. And by doing that, you kind of prove it. Once you've done that, you can start building confidence. And maybe you are just starting on internal tooling, internal services, or a small service that's low risk. But as you build the process and you get things like I like to call PreCap in, and make that work, and support become more kind of invested in it, and they see the benefits because actually they're getting lots of decent information now. You're sending them loads of automated monitoring and alerts, so their job's becoming easier, and it's easier for them to then get across more stuff, and it just, the whole process kind of proves itself. And the hardest thing is build it. You just need to build it and make it work and show people that it works. And that is kind of that. So I know it's a bit of a whistle-stop tour, and I hope I've not skimmed over too much and you found it interesting. Thank you very much.
Thanks, Tim. That was really, really interesting. I don't know if you kind of saw the chat throughout, but some really great feedback already. You know, like people thinking it, you know, some really good tips in there. If anybody's got any questions, if you pop them in the chat, and I'll ask Tim some if you've got some time, Tim.
Yeah, absolutely. Sorry, yeah, I've not got enough windows, so I can only see one. So I'm just looking at the questions now. Yeah.
Yeah. So people, you know, just saying how much they enjoyed it. Someone's asked, Josh has asked, what service are you using for your pipelines?
Yeah. Okay. That's very good question. So we are all AWS. So everything we do is in the cloud. So it's all basically compute instances. We use a tool called Drone to do the continual integration, which has its pros and cons, I won't lie. It's very slimline, it's very small, which means it runs quickly. It's quite easy to sort of administer and look after. But it lacks features that are sort of bigger CI system, like let's use Jenkins as a old school example used. But yeah, to answer the question, we are on AWS, so everything runs in cloud, which makes, I realize it makes doing this an awful lot easier, right? Because you can spin up environments really quickly, really simply. We use Terraform, so infrastructure as code to do it. which again makes it very easy because we can run up in environments, run up servers, services really simply by code. So that makes it easier. It really does.
Okay, cool. I mean, you might have just answered this. Someone asked, does it differ kind of on premises to cloud? Is that kind of covered in the last answer?
Yes.
Yeah.
So it depends what your on-premise looks like, really. If you've got actual hard, tin with that's not virtualized in any way, it becomes more of a management issue, I'd say, in terms of like answering, that how do we set up a load of test environments for a whole bunch of different teams so they're not treading on each other's toes when they're trying to do commits and that, it's harder. But you can still on-premise and do your kind of hybrid cloud stuff, or use something like Ansible or VMware, driven stuff. So it is doable, but if you've just got hardware, I admit it's more of a technical challenge to make this work.
Okay. Guy asked if you've got any tips on coordinating the release when your app is split into multiple parts.
So, in terms of, let me just scroll and find this question, just so I can keep referring back to. Okay, yeah, cool, got it. Yeah, another good point actually, and I think you almost have to tackle this in a cultural way as well as a technical one. Ideally, each engineering team you have should be kind of focused on one sort of complete thing. Now we're kind of microservice world, so any given microservice we do is owned by one team, so that immediately makes it easier, and it makes it easier that you're just working on your little part. So as long as you are then sort of thinking, right, okay, well, I'm working on this part, and I know if I change this interface, then this team over here, that might affect them. So, right, okay, that's an actual problem. So how do we do that? I mean, obviously, if you're all in the same building, it's a lot easier because you can just walk over and say, well, we're doing this, what do you think? Which is great. When you need to start scaling, it becomes more difficult. So we can use something, and we do use this, something called contract testing, where you actually sort of define between the bits of your application that you sort of say, right, we have a contract for this API. So we promise we won't change anything in our API unless we publish it to the contract first. And if we do that, we're not allowed to actually do the work until you accept it. And that backed up with versioning of versioned APIs means you can coordinate. Again, it's one of those things that you do need to think about and work out a way of doing, but there are ways you can automate this. We use Pact, I think it's called, Pact.io, I think it's the website. Definitely check it out. It's really good. I think you're on mute.
Sorry,
Molly.
yeah, I muted myself. My phone was ringing. Yeah, Lucy asked what the biggest piece of advice you would give to somebody who's just kind of starting out with this.
Yeah, that's really good. You know what? I don't know in how to answer that really, because I'm kind of one of these old gits who's been in the industry for too long now, and I kind of just naturally got here. I think the build it example is the best thing you can do, is actually build something with a pipeline that immediately pushes out to a production environment. That's really simple for me to say in a company like DAZN, where we've got all the support and we can just spin up environments as and when we want in AWS. So there's lots of good resource around there. I mean, this all feeds into the sort of more DevOps kind of world, so definitely do some reading around the DevOps kind of mindset as well, and how the platform's all part of the code's all part of the platform. We, like I just intimated, we do infrastructure as code, so we've got our infrastructure lives in our code repositories, which makes it easy. But first up is like that test pipeline. I think is probably one of the most important things you can do. it's, you know, build those stages up, make sure your testing's good. Whether you do test-driven development, behavioral-driven development, or you do your tests afterwards, possibly, you know, do it as you go along. It's probably the best thing to do. Get your tests right. That the automation testing is so vital to make this work. It really is. So any sort of, you know, start understand. Don't expect to write code and throw it over a wall to a QA. That's never going to work in this kind of way of working. You need your QAs, your software developers in tests, software engineers in tests, whatever you want to call them. They have to be in the team. They have to be part of the team. They have to be writing the tests with you, writing the code. And, you know, you should be writing tests. You know, your SDET should be code reviewing and making sure the tests that the developers write are good and make sense.
Fab. Okay. Daniel said, why do you repeat smoke and system tests on the different stages? What are you hoping to catch there that you didn't manage to catch on the previous stage?
So, yeah, I could chat for hours around what do we do with a stage environment? Why do we have stage? And it's almost like a traditional thing, I think. The reason for running all the tests that we run in the test environment is that's where we'd have evergreen data for testing, and we run all of those. The smoke tests are there basically to make sure our infrastructure is actually stood up. So every time we deploy, we're potentially redeploying lambdas, we're changing a database schema maybe, we're spinning up a queue or a notification service. The smoke test is just there to make sure that it actually did it and that the services are actually up. You know, when I don't now very much in a cloud sort of world, but, you know, are the load balancers set up correctly? Are they routing traffic the right way? Is your DNS correct? Has the S3 bucket got the data in it you need? And all those things, that's what smoke test is for. And you need to do that in each environment. And the system test is more just a sort of sanity test of like, okay, the smoke tests show that the stuff's there. This, you know, in old school thinking, the servers are there. The system test is just, there will be much less as you go right on that pipeline, if you remember it. As you get closer to production, your system tests probably are actually smaller suites. You're just literally sort of thinking, our main happy path here is, you know, user can do A, B, or C, and we expect X, Y, or Z out the other end, and it's just running something like that. It's just sanity checking, really.
Fab. Okay, cool. Let's just see, you've got a couple more questions. Lots of people with lots of compliments for you. Really enjoyed the talk. For anyone that's asking about it being recorded, it is all recorded and it goes onto our YouTube channel, so we can get the link sent out for that, or just have a look on YouTube for Fruition IT. Okay, somebody has said, what are the triggers to start and stop the watch when you are measuring mean time to recovery or discovery?
Yeah, good. So our mean time to discovery is from when code hits production to when someone reports it. Be that an automated alert picks it up and reports it, or a user or a customer even reports something into our customer service. So again, you know, this might be different for every project even. It certainly is going to be different for each company and how you work. You know, I've tried to sort of come at it this sort of relatively high level because everyone works in different ways, and that's, you know, absolutely right. We've all got different problems to solve. So yeah, that mean time to discovery for us is from when code hits prod to when someone says, hang on, this isn't right. Then the mean time to recovery is basically when's the fix being rolled out. Ideally, the difference between your discovery time and your recovery time is small, but it is what it is. It's just for us, or certainly for me, a more useful metric is that mean time to actually discovering something's gone wrong. And that's where this sort of measure everything piece comes in, and where good monitoring and alerting really, really helps you. Ideally, you as a team find the problems before anyone else sees them, and you fix them before anyone else knows there's a problem. Ideally. Doesn't always work that way, obviously, but
okay, Will asked if you have experience of CICD working in a regulated environment with big corporations as customers. Process management becomes a big deal for these organizations.
Yeah, and it's difficult, and that's a challenge. And until you win hearts and minds over, you're going to struggle, to be perfectly honest. You know, we're kind of lucky in DAZN in that we've kind of, the sort of engineering department was set up in a very sort of like, you know, agile DevOps mindset, very sort of trying to be a startup kind of mentality. And it's really easy to do when you're building it in from the beginning, you know. And we don't do this all across the business. This is just, I'm just talking from my experience in Leeds here. So it's not like we're doing this everywhere, but we can make it work. Now, where there's process management, then it might not be appropriate. Maybe continual deployment isn't, you know, it's not going to work for you, and that's fine. You can still do the continual delivery, and I still say most of that pipeline still works for you. You can still deploy up to stage, for example, or UAT, or whatever you want to call, you know, an environment where someone can look at it. We just go all the way to prod because it basically meets that golden rule of master branches what's in production, which makes coding and recovering and debugging and iterations so much easier. But if you can't do that because there are massive processes in the way, because you've got, like you say, big corporations, then it is harder to do. But I'd definitely encourage looking at the sort of pipeline and these sort of pipelines. Even if you don't go straight to prod, you're still building up decent release artifacts, for example, in stage. And that, I think, hopefully that's useful and makes your development process easier.
Fab, thank you. Matt said, what is a mutation test? He hasn't come across that before.
I wondered if someone would pick up for this. So mutation tests are something you apply to unit tests or after unit tests are written, and they take your code and mutate it. So say we're testing a unit test is passing, your mutation test then actually changes the code that's under test. And then if your unit tests don't fail, the mutation test is a failure. So what it's actually doing is checking that your unit tests are good and actually useful and providing value. And if they're not, there's something wrong with your unit test and you need to go address that. We use Striker, spelled with a Y, not an I. Yeah, check it out. It's really good, really cool tool. I had never heard of it until about 18 months ago when some of our QAs came back from a conference raving about it, and now it's invaluable. It's brilliant.
Thanks. So Charles has asked, the biggest challenge in his experience is to change the culture of the current dev team, and also, and equally important, the culture of the business. This is so important to ensure positive success. Have you had to do this in the past? And if so, how did you tackle that? Yeah.
With the dev, yeah. So dev teams is an interesting one, actually, because if your devs are anything like me and how I was, it's like, I was very much a kind of like, no, my way is best. I know best. I don't need change. Change is scary. I don't want to do change. And it's difficult. And I think you have to, again, like I sort of alluded to, is like pick something small and just say to the, get the teams to say, okay, look, let's give this a go. Maybe it's rubbish. Maybe it doesn't work for us. Maybe we hate it. But give it a go. Put it into practice and then start seeing the benefits it can give you. And you start winning people over. I mean, my biggest challenge, I think, in doing this was the CAB one, which is why I banged on about it a bit more in the presentation. It's like, I was trying to think of ways to get around CAP, and how do I go circumvent it? How do we just like do it just sneakily, go under the radar and do stuff? And long term, that's not a realistic approach, especially in a large business. And it just struck me as like, well, what's the actual problem here? Why is this an issue? Why do we have to wait until we're just about to release to let the business know we're making a change? And it's things like that. Try stepping back a little bit from any resistance you get and sort of kind of break it down to that, actually, what is the problem they've got here? Because they say it's this thing, but maybe actually they're just worried about something else, and we can address that in a different way. It's kind of, I hate using the buzzword, but kind of like out-box thinking a little bit around the problem. And the response I had from change management when I suggested, look, why don't we do this? We'll still tell you what we're changing and when it's going to happen. Is there any reason you need to know right before the time? And they went, well, no, it'd be brilliant if you told us weeks in advance, we can prepare. And all of a sudden, what was a problem was no longer a problem. And actually, the change management people really, really have been really good. They've loved the new process. They love the way we started to do working, and they're really, really impressed with it. So much so, they want us to sort of, sell this internally as well. So again, just come at, maybe if you're running into a brick wall, maybe come at a different angle, which is a bit of advice. I know it's a bit fluffy. I realise depends on the situation, I guess. But
Warren suggested that perhaps the best way to get started is keeping it simple with the trail-free build processes offered by Git, Azure, and Bitbucket.
100%. Yeah. They've all got their own CICD tooling involved. GitLab does as well, or you can look at things like Circle CI. I mean, you can do it with anything really, even if you're writing a whole bunch of Bash scripts. I mean, I wouldn't advise that, but it's doable. But yeah, Amazon have got CI/CD tools that you can use, and they're improving all the time. There's lots of tooling out there, and you have to sort of look at what you have and what infrastructure you're working on, and see what's the best fit out there. Almost guarantees someone out there's done it already, so have a look around, find something, and again, try it out. Just try it out. It's the best way.
Guys just asked, what's the best way to have interruption-free release for users in blue/green environments?
So that is, I kind of guess that's dependent on what you're releasing, right? So in a blue-green, interruption-free, I mean, it's how you cut over, I suppose. If you can do it, I'd always recommend Canary, but that's not always possible. Again, it depends what you're changing, and there's always going to be outliers and weird cases where you don't want to, for example, my sort of change freeze window thing, maybe you have a time of day when you have peak usage, in which case wrap a little change window around it. Say, let's, everyone's, not knowing what your problem is, and what problems you're solving, but is there a time when let's say you have peak usage between 12 and 2 every day because people are doing things that they do on your system over lunch. So just wrap a little, like, well, let's not push anything in that time period. Let's wait until afterwards, then flip over or blue-green. Maybe you want, and you've got process that means, right, we've deployed to blue, green's currently what customers are seeing. Let's do our testing first in blue. We're happy, and then maybe that's a manual cutover for some people. Again, it's, nothing's a magic bullet. This is, and every business and in fact, every problem within each business is going to have its own nuances and things that you need to solve. So yeah, I kind of guess that was a bit of a get out answer. Sorry. But yeah, I mean, there are strategies you can use, I guess. I mean, without knowing more about your kind of problem set, it's hard to give a definitive answer, I reckon.
Fab, thank you. David asked, how does it work in a regulated environment? For example, if it was a government department?
Yeah, so I guess in highly regulated departments, again, you probably need to kind of write the process around it if you really want to, really want to do this. And it genuinely does bring benefits from the engineering point of view and from the quality point of view. In my experience, because you make small releases all the time, you're good at releases because you do them all the time, and every single release you do has got a really small blast radius. So if something does go wrong, the chances are it's not actually going to have a major effect. Obviously, there's always edge cases, but it's then, if you've got something like a government body who have very strict regulation and process, then it's, it's a marathon, not a sprint. I would suggest you have to start chipping away at the process. And again, it's like, question process, question why do people do things? Why is this a thing? It's like, why some companies still work on waterfall, and you have to ask why, and maybe there's a decent reason for them to do so, but why is that? Sometimes that question, why are we doing things this way, actually makes people stop and think about it, and that's how you start making change. But I know government organizations, that is hard to enact. And again, I've got no kind of magic wand I can wave to help on that, really, other than just got to start chipping away and start winning hearts and minds over. And it's not easy to do. It isn't easy to do. I guess, if I'm kind of going off on a little tangent a little bit, it's like, talk to people. If you want to make the change, actually talk to people. Go, rather than sending an email. If you